Hey. What's up?
Hey, so data resiliency. How are and this is also
Yes,
interesting too with the recent events. Well, later we'll talk about disaster recovery. We talked about
exactly.
data gravity earlier. Data resiliency, I'm sure, is going to have something to do with what happened a couple days ago. Facebook, WhatsApp, and Instagram simultaneously having these kind of issues. If you want to share your screen, go for it.
Oh, yes, sure. And I have actually put up some content regarding that also,
Very good.
like the thing that happened 2 years, 2 days back. Sorry. So let me just pull up my screen. So should I just share my entire screen or just tab?
Yeah, just whatever you want. If you share the whole thing, then we'll see the whole thing. You can just identify the window, or if you just want to do the tab itself or the
Uh,
slideshow, that's fine too.
sure thing. Yeah, yeah. So is it visible?
Yep.
Sorry, the last slide. Yeah. Just go to so, beginning. Okay. So let's start data resiliency on Kubernetes and basically for DoK Students Day. So let's learn about data resiliency. But before that, let me just introduce myself. So this is me. I'm Purneswar, and I'm a final year student at NIT Rourkela. It is in India, and I'm an incoming software engineer at a company. And I'm recently learning the new container instance technology and Kubernetes and other technology involved in the cloud native spaces. And you can connect me with in LinkedIn and in GitHub. I'm present and very active in both of these platforms. So enough about me. So let's dive into the content. So what is resiliency? But before that, let's understand what is redundancy. Now, redundancy is something something that is two or something that is repeated. So there can be two systems, there can be two networks, and stuff like that. So basically, the goal of redundancy is if one system will fail, other will serve as a backup. Like just in the example, we are considering two buildings out there. So they're connected by fiber optic cables. So just in case one of the fiber optic cables goes down, we have another backup cable to serve as a backup. But there is a problem. Like there can be many factors while involving this fiber optic cables and all, because if there will be some construction out there or there will be some ground pests like rats or something, if they destroy one of the cables, then there is a chance that the other cable which might be laying just next to it, it might get exposed. So flaw in the one creates a flaw in the rest. So that is a big problem out there. So just to save that, we have resiliency in our hands. So resiliency is defined as something, if there is a problem, we need to recover from the problem. We need to converge back to the original state, and the process in which it is converging, in that process, it should fail fill the system itself. So just the example that we took earlier of the fiber optic system, it can be shown exactly like this. Like like instead of laying both the cables right next to each other, we can connect it to other portion of the building so that if one of them gets destroyed or one of them gets exposed, the other one is very quietly safe out. So this is a very nice example to understand resilience in general. So let's understand what resiliency is defined in technical terms or in the cloud. So basically, resiliency does not mean that the system will be available when there is some problem or there's an event which triggers the problem. Resiliency means that the system will self-recover itself back to its original state. And basically, there are certain engineers assigned for the role who engineers who work for a certain company, and the company has certain clients, and these clients have some pacts with the engineers, some contracts with the engineers to have a particular uptime for the systems Like uptime is something when the system will keep running, and that uptime is measured in some percentages, like it's 99% or 99.5%, like something like that. So engineers basically give a term, and that term is called availability. So the amount of time a system will respond to a request from a user, it's called availability. And an engineer should always see that the system has high availability out there to be very resilient in such conditions. Now, this is a very complicated diagram to see up front, but the thing is, when there is a for example, we send a certain request to the to in our when we browse on the internet. Let's we are searching www.instagram.com. So that will be sent to the servers of the Instagram, and there are certain things called load balancers. And basically, load balancers are basically like the word is sufficiently describing it. Like it balances the load which comes to it. So it sends to multiple backend servers who processes the request and tries to fulfill it. So basically, this ensures that if one of the server goes down, the other servers will be there to fulfill the request. Now, why do we need resiliency? Because downtimes are the biggest problems in production out there. And the best example is just what happened 2 days back. And Facebook, just so that every one of you know, has lost $6 billion in the time of 12 hours. $6 billion, and that is not a very small amount to for a company like Facebook. Like 2 to 3 richest persons of some countries might not be if we accumulate their worth, they might not be of $6 billion. So it's a big loss for a company like Facebook. And it's not Facebook alone. Like in the past, we have seen Apple, and even Facebook has suffered a loss of around $90 million, and Apple has suffered a loss of $25 million. And these are some examples which say why resiliency is a very big factor when we discuss stuff like how systems will be resilient and all. So since our talk is basically on Kubernetes, so let's understand how resiliency and Kubernetes are related to each other. Now, just so that we are all on the same page, Kubernetes is something which manages workloads. Like if we try to run an application, Kubernetes will run the application in a form called containers. And basically, containers are nothing but the application is divided into small, small fragments, and Kubernetes will try to run that. And what Kubernetes does special is it can scale your applications or make your applications more dynamic, more accessible to people. And this is done by something called the declarative approach of Kubernetes. Now, Kubernetes is declarative rather than imperative, has a whole special talk and has a whole special domain of knowing things. So let's just understand what this declarative approach means through this certain diagram. Let's just understand the architecture, how Kubernetes is built. So there is something called the master, or we can say it's the control plane. Like to understand Kubernetes, we can say something like, let's understand the body. Let's understand the body of a lizard. Why did I take the example of a lizard? It's because if you see, when a lizard's tail is cut, it regrows its tail. But if you kill a lizard by stabbing its heart, I know it's kind of very brutal, but yeah, if you just stab its heart out there, it will instantly die. And this is how Kubernetes works. So there is something called the control plane, and control plane has the heart of Kubernetes. The heart is called the API server. It also has different parts rather than just the API server, but let's just concentrate on the API server. Now, if there is a workload which is try to running on Kubernetes, the API server will create that workload in something called as a pod. Well, the definition of a pod is a whole different topic, but let's just imagine pod as something like a bubble which contains a workload. Now, to run the workload, we need worker nodes. And since heart is the basic and the most fundamental thing of all organisms, and everyone watches the heart, if the heart stops, when organisms die. So everyone, the worker nodes also watches the API server, and the API server is creating a pod, and everyone watches that. So now this pod will be assigned to one of the worker nodes out there. So let's assume that the pod or the workload will be assigned to the worker one. Now, there can be a problem. Like, as in the lizard example, if the tail gets cut. And similarly, in the Kubernetes example, if the worker goes down, then the tail regrows. So it always sees that the heart is running. So the heart says that we need the workload to run or we need the application to run. So the worker node fails, and in that moment, that same workload will be transferred back to the worker node 2. So this is the best and the most efficient example of resilience, which you can say. And Kubernetes is a maestro in doing it. So this all happens, and there is always a smooth functioning of workload. And this is how resiliency and Kubernetes are related, and they're very, very strongly related. Now let's get into the part how our community, the DoK community, is a very big part in data resiliency in Kubernetes. Now the first point is implementation of stateful and stateless workloads. This is something which you always discuss in our webinars, in all of our talks that happen on YouTube, on live. We always ask the persons who give their talk about stateful and stateless workloads. And to define stateful and stateless workloads, if there is some stateful workloads out there, stateless, let's just ignore stateless since they are stateless. But if there are stateful workloads, we need to have the state intact. So for that, the system must be resilient. So that's implied. And the other thing is, for the community members, there is a new paradigm of whole knowledge and just to gain knowledge on resiliency testing. Like CNCF has this thing called chaos engineering. Chaos engineering is something like systems are tested for their resilience out there. And for the community members, it can be a whole great and very awesome career path out there. So people can check out chaos engineering. It's there in the Kubernetes Slack. And join our community, join the DoK Slack. That will be great. We'll be very amazing. We're meeting very, very amazing people, and we'll be glad to have you. And there are a lot of folks who are very interactive, and beginners are welcomed out there. This is how I started my journey, and this is how maybe you can start your journey also. So let's catch up. What are redundant systems? We read it earlier. Redundant systems make the safety level meh. So resilient systems make the safety level, we can just say yo, yeah. So and yeah, check out chaos engineering. It's an awesome career path. And the next, learn about the god of resiliency, Kubernetes. There's a whole lot of things out there to learn about Kubernetes. Once you dive into it, your world will open into a very, very new domain of things, and you will love it. Yeah, this is a meme. One time I tried to explain someone Kubernetes, and then we both didn't understand, because I'm just giving you this example. If I say something about Kubernetes right now, there might be a chance tomorrow that will be invalid, because it is open source and everybody is working on it every hour, every second. So there is research and there is new progression every day. So, but we can always try to bring folks out there into the community and learn more. So welcome to QPath. If you're interested, here is some resources to get you started. The stakeholder is Nana, which is a very amazing site on YouTube. You can check their Docker and Kubernetes playlist. There's a intro to Docker and intro to open source by the DoK community itself on our channel, on a YouTube channel. You can check it out. And join the Kubernetes Slack ASAP if you haven't joined. A lot of folks out there are waiting to meet you and waiting to greet you with amazing resources to learn and to interact with you. So join it and have fun. So these are some credits and shoutouts to people who have been a great help in my journey out there. Kunal Kushwaha, as we all know, he is great out there making awesome content for students, for upcoming learners, and even for someone like me who is new to this community very late, but Kunal has helped quite a lot, and this Madhav and this Devavrata, he's from my college and he did an awesome lot of stuff. Madhav helped me in the Kubernetes itself to learn a great lot of things. See, when you join a community, you get to know these people, and this is great. I've been knowing these people on some of them on a very personal level and some of them on a superficial level, but they have been a great help to me. So never hesitate to join new communities as there will be a great learning path for you. And thank you. Have a wonderful day. You can connect with me and join our Slack ASAP. That's all from me right now.
Very, very well done. Excellent presentation and also an excellent invitation to the community. And I think this is a common thread that we're seeing in a lot of the presentations, but very, very well repeated and well stated in yours. It's pretty simple. Just take the step, right? We're here to help you. Lots of other people have taken the step. Nobody has died in the process. I repeat, not a single person has died. No one has been injured. I don't think anything has happened in terms of negative consequences.
Nothing like that.
So it's very, very simple. Anyway, thank you very much for your presentation. Now we're going to move on to the next one. Let's get, absolutely, thank you.